Today's story is the answer to the March 2024 puzzler. Scientists consider about 1% of Earth's 200,000 glaciers to be surging. This type of glacier goes through prolonged periods of quiescence and slow ice flow, when extra ice builds up at high elevations, followed by periods when ice lurches forward in a burst, in some cases flowing 10 to 100 times faster than normal for periods of months to years. Surges typically begin when excess meltwater builds up along the bottom of a glacier, lubricating the contact area between the glacier and ground and making it easier for the glacier to slide. Though it varies by glacier, surges usually last fewer than 2 years and occur every 15 to 100 years. Changes during surges can be dramatic, especially when glaciers flow into the ocean. When this happens, extra water infiltrates the land-ice interface, allowing the glacier to slide even faster, sometimes by tens of meters per day. When surges subside and marine-terminating glaciers enter the inactive part of the cycle, waves and tides can beat back the glaciers as quickly, or even more quickly, than they advanced. That's what has happened in recent decades at Sortebræ, a large surge-type glacier in eastern Greenland that drains into a fjord that leads to the North Atlantic Ocean. The pair of Landsat images above illustrates how much the glacier has changed in nearly 4 decades. The image on the left, acquired by the Thematic Mapper on Landsat 5, shows Sortebræ and several of its tributary glaciers in 1986, 6 years prior to a period of surging. The glacier's main trunk and its tributaries flowed together into one stream, creating a distinctive shape resembling an icy pie symbol. The image on the right, from the OLI, Operational Land Imager, on Landsat 8, shows the same area in 2023, after the tributaries had narrowed their fronts and retreated, taking a large bite out of the pie. Notice the long brown lines running along the length of Sortebræ, which means black glacier in Danish. These are lateral and medial moraines, piles of rock and sediment deposited on the edges of the glacier or where the tributaries met. Normally, medial moraine lines follow the path of the glacier, but surging glaciers intermittently flow so quickly that they can form striking bends and kinks called looped, or sometimes bulging, moraines. Over time, these moraines got dragged down the glacier to form the characteristic tear-shaped moraine loops visible in the image, said Hester Jiskoot, a glaciologist at the University of Lethbridge. Another telltale sign that this is a surge-type glacier is the pitted, Swiss cheese surface visible in the 1986 image, a pitted pattern caused by the filling and draining of small lakes or the closing of crevasses on the glacier surface, she added. The main branch of Sortebræ surged forward between 1992 and 1995.